Now, dear students, continuation of the progression's next part, learning objectives. How to obtain the formula for finding the sum of n terms of an arithmetic progression. How to find the sum of the given number of terms of an arithmetic progression. How to find Sn and n if first term common difference is given. How to find two quantities if two quantities are given, just like above. How to find the sum of number of divisors of a given particular number. How to apply the formula, Sn formula, in daily life problems. So now, sum of first n terms in arithmetic progression. Now let us discuss this concept. Children, we already take an example in nth term. Here also we are taking the same example to understand this concept. Let us consider a situation. Hema put ₹1,000 in money box when her daughter was 1 year old. ₹1,500 on her second birthday, ₹2,000 on her third birthday, and will continue in the same way. It means here her mother Hema saving or giving every year some amount of money. So in first birthday she gave 1,000 rupees, in second birthday 1,500, in third birthday 2,000, like that. How much money will be collected in the money box by the time her daughter 21 years old? So at the time of her 21 years old, so how much money will be collected? That is the sum. Here, the amount of money put in the money box on her first, second, third, fourth, up to so on birthday, respectively 1,000, 1,500, 2,000, 2,500, up to so on till her 21st birthday. So see the amounts particularly here. First amount 1,000, next amount 1,500, then next 2,000 and 2,500, up to so on. It is gradually increasing by 500. Okay. Now, to find the total amount in the box on her 21st birthday, we will have to write each of the 21 numbers in the list above and then add them up. Don't you think it would be tedious and time consuming process? Isn't it? So if you write all the 21 terms in the long list and adding them, it is taking the tedious. It means it is very hard and also time taking process. So that's why. Can we make the process shorter? Let us see. This would be possible if we can find a method for getting this sum. Okay, now. So, to find out these type of sums, a scientist Gauss found a formula. Actually, he found this formula at the age of 10 years only. That's why he became a mathematician, scientist. So now, regarding this situation, I want to tell you a story. So, whenever Gauss on 10 years old, his teacher taking a math class. So in that class, the math teacher asked the children, find the sum of first 100 natural numbers. Then every children take a notebook and start the finding out the sum. Just like 1 plus 2 plus 3, 1 plus 2 equal to 3, 3 plus 4 equal to 7, like that they are started. But Gus get up and tell the answer in few minutes. Tell the answer in few minutes. What is the answer? He told 5050. Then teacher shocked. The answer is correct. So how can he do that one? Okay, let us think over it. Now once again, let us see that situation. We consider the problem given to Gauss to solve when he was just 10 years old. He was asked to find sum of the positive integers from 1 to 100. He replied that the sum is 5050. Can you guess how could he do it? So you take s is equal to 1 plus 2 plus 3 plus up to so on 99 plus 100. That means you take the sum of all the 100 natural numbers like this. And then reverse the numbers to write s is equal to 100 plus 99 plus up to so on 3 plus 2 plus 1. And then when he added these two term by term, he got s plus s. Left side s plus s is equal to 100. On right side 100 plus 1 plus 99 plus 2 plus up to so on 2 plus 99 plus 1 plus 100. So then he got in each and every bracket a result as 101 plus 101 plus up to so on 101. So here how many 101s are there? Obviously 100 times. Why? He is asking for the 100 times, sum of the 100 times. That's why it is repeated automatically 100 times. Then next, s plus s is equal to s, that is equal to 100 into 101. Then s is equal to 100 into 101 by 2. Then, so s is equal to simply put it by 2 table, 2 ones are 2 50s are 50 into 101, then we get 5050. That is, the sum is 5050. So now we have to find the actual formula which is helpful to find out that mass data amount. Okay, that is the total 21 amounts, the total of the 21 amounts. The sum of entries of an AP is very much useful to find out that sum. Okay, now we will now use the same technique that was used by Gauss to find the sum of the first n terms of an AP, a comma, a plus d comma, a plus 2d up to so on. So that means here already we saw that terms which are in AP. That's why here we have to take the AP terms which are a plus d, a plus 2d. Then automatically nth term we know. What is the nth term? AP is equal to nth term of the AP is equal to a plus n minus 1 into d. Now let Sn denote the sum of the first n terms of the AP. Then next, then Sn is equal to obviously a plus d plus a plus 2d up to so on a plus n minus 1 into d. Now by changing the order we get Sn is equal to a plus n minus 1 into d plus a plus n minus 2 into d up to so on a. Here observe the second term. We are writing in reverse order. A plus n minus 2 into d. So to get the previous term to the a plus n minus 1 d, we have to subtract 1 from the n minus 1. That is a plus n minus 1 minus 1 d. So that we get a plus n minus 2 into d. So up to so on a. And then adding by term. So the above two SNs are added by term. We get 2 into S1 is equal to 2a plus n minus 1 into d plus 2a plus n minus 1 into d up to so on 2a plus n minus 1 into d. Then again these brackets are how many times? N times. And then 2Sn is equal to n into 2a plus n minus 1 into d. Then Sn is equal to n by 2 into 2a plus n minus 1 into d. Sorry. Then Sn is equal to n by 2 into the 2a can be written as a plus a. So a plus n minus 1 into d. So here observe one thing. This formula can also be written as Sn is equal to n by 2 into first term plus nth term. Generally this nth term is taken as an. So that Sn is equal to n by 2 into a plus an. So this is a formula to find out the first n terms of the given terms of AP. Okay. Now, if the first term and last terms of AP are given and the common difference is not given, in that case we have to use Sn is equal to n by 2 into a plus a. It's very useful to find Sn. Or Sn is equal to n by 2 into a plus l. In general, an is also taken as l for last term, where l is the last term. Now, let us take the example of a mass starter. Okay, so we have to find the amount at her 21st birthday. So the amount of money in the money box of a mass starter on 1st, 2nd, 3rd, 4th birthday were 1000, 1500, 2000, 2500 up to so on respectively. Then by observing the above progression, this is an AP. Already I said no, it is gradually increased by a constant term or a constant number, that is 500. Okay, so this is an AP. We have to find the total money collected on her 21st birthday. That is the sum of first 21 terms of this AP. So see children, we are getting the short way. Okay, here A is equal to 1000, D is equal to 500 and N is equal to 21. Using the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. By using this formula we can write Sn is equal to, or S is equal to 21 by 2 into 2 into 1000 plus 21 minus 1 into 500. Simply by substituting the n value 21, a value 1000 and n value 21 and d value 500. Okay. By substituting this, we can get easily 21 by 2 into 1000, 2000 plus, and again here 21 minus 120, 20 into 500, 10,000. So totally we get in bracket 12,000, that is 21 by 2 into 12,000. So by cancellation we get 2 and 12,000, we get 21 into 6,000. Multiplication we get the result as 1,26,000. So that is the amount got by the mass starter at her 21st birthday. So like this way we can shorten the tedious result. Okay, no need to write all the lists of the 21 numbers and no need to add them in that bigger way. So in this shorter way you can find easily the sum of n terms. So by this way you can understand how to get the sum of n terms of a given AP. Okay, so by getting the concept of this Sn is a Sn formula, you can never forget this formula. You can use in your daily life problems also. Okay, now let us see once again. Here we use Sn in place of S. We use here actually Sn in place of S to denote the sum of first n terms of the AP. Okay, in place of S generally we can use Sn, where Sn denotes the sum of the n terms, so that we know how many terms we have added. So just before sum we added how many terms? 21 terms. So that's why there we can use S21. So for example, if we write S20 to denote the sum of the first 20 terms of an AP, the formula for the sum of first n terms involve 4 quantities. Okay, you can observe that one: Sn, A, D, N. Here A is the formula, D is the common difference, and N number of terms. And then we have any 3 of them, we can find the fourth. Okay, now important note, what is that? The nth term of AP is the difference of the sum of first n terms and sum of first n minus 1 terms of it. That is, n is equal to Sn minus Sn minus 1. Okay, so while doing we will discuss once again this formula, just you can recall it. Then here the nth term of AP, if you want to nth term of AP from the given result Sn and Sn minus 1, just you can subtract those two, you will get the nth term. And then once again see the formula of sum of the n terms. Formula for the sum of the n terms of an arithmetic progression: Sn is equal to n by 2 into 2a plus n minus 1 into d, where n is equal to number of given AP, a is equal to first term, and d is equal to common difference, and Sn is equal to symbol of sum of the n terms of an AP. Okay. So like this we can understand the sum of the n terms of the progression formula. Okay, now in next video let us discuss the sums on this formula. Thank you.